this video, we're going to be calculating a series circuit with a random unknown. I've titled this circuit Example 1 because based on the book that you're using, this circuit could be either figure 439 or figure 440. So we're going to call it Example 1. Now what's unique about this circuit is we're not given all the values. That's why it's called a random unknown. So if you look at R2, you're not given his value. If you're given R3, you're not given his value. But what we want to do when we're solving our random unknown circuits, and really any circuit for that matter, is we want to start by filling in what we do know. So what do we know? We do know that 36 volts is our VT, and they also have given us our V2 of 12 volts. The next thing we see is that they have given us a current. Now, based on our series rules, we know that if we get current anywhere, we get current everywhere. So they've given us our current. That means we can fill in all of our current values, 1.2 milliamps, because current stays the same in a series circuit. Alright, so I have filled in all of my current values. What else do I know? Well, I know the value of R1, which is 3.3k ohms. I don't have R2, I don't have R3, but I do have R4, which is 4.7k. Alright, I'm going to save power till last. They didn't give me any values, so I can't fill in any, and I'm going to calculate those last. So let's just focus on the voltage column, the current column, and the resistance column. Now if we can get 2 out of 3 of any of these, we can solve for the third. So we can see here for RT that we have VT and IT. So we'll just use our Ohm's law formula right here. That shows us that RT is equal to VT over IT. So we have 36 volts over 1.2 milliamps. That tells us our total resistance is 30 kilo ohms. So the next thing I can solve for is R2. R2 is going to be equal to V2 over I2, as we see right here, V over I. So what is V2? 12 volts over I2, which is 1.2 times 10 to the negative third milliamps. When I hit equals, it's going to give me the value of R2, which is 10k ohms. Alright, I only have current for R3, so I don't have 2 of 3. I can't solve for him yet. But I can go ahead and solve for V1, which is 3.96 volts. Next I can solve for V4, 5.64 volts for V4. So I see that I'm still missing V3 and I am missing R3. So there's a couple of different ways I can go about solving this, but basically I can determine the amount of resistance for R3 because of the rule that I have concerning resistance in a series circuit. And by observing this rule, it shows me that I can rearrange this formula to find this missing value with this equation. R3 is going to be equal to the total amount of resistance, which is RT, minus R1, R2, and R4, and this will give me the missing value of R3. So let me punch that into my calculator. This will give me the value of R3, which is 12k ohms. So at this point I can solve V3 in a couple of different ways. I can do V3 is equal to I3 times R3, or I could use basically the same formula. V3 is equal to VT minus V1, V2, and V4. Now a while ago when I calculated R3, instead of that, done V3 first with this equation. It's really a matter of preference. You can get there either way to fill them all in. So let's go ahead and just do the I3 times R3. Punch those numbers in, and that gives me a voltage on V3 of 14.4 volts. As always, we can add up 1, 2, 3, and 4, and it should give us the same number of VT, 36 volts, that IT times RT should give you. That's a good way to check your work. So we've saved power till last. Looking at our power formula, PT is going to be equal to IT times VT. So let me punch in my So let me punch in my IT value. So I take my current of 1.2 times 10 to the negative 3, which is 1.2 milliamps times 36 volts. I hit equals, and this gives me the answer of 43.2. I'm looking for power, so it's milliwatts. Now you might have noticed when I hit equals, I'm not getting a fraction. And the reason why I'm not getting a fraction is because I'm in math mode 2. I just changed it back to math mode 1 just to show you. So now when I hit equals, it gives me a fraction. But I can always get to engineering by hitting engineering. But if I don't want that fraction, I go shift, mode setup, math 2. And if I'm in math mode 2, when I hit equals, it's going to give me a decimal. Then engineering. And remember, you can be in math mode 2 whether you're in normal math mode or scientific mode. Alright, so I calculated my PT, and basically I can just go up here, change the voltage to 3.96 volts to get P1. I'll follow this same procedure to get P2, to get P3, and P4. I'm going to leave the current in there and just scroll up and change my voltage amounts. And you see here all the values of my power.